Today, hopefully everyone here is interested in knowing about monoliths and how we can actually take them forward. So let's get underway. Firstly, we need to thank our sponsors. As we said, Dev Express, if you haven't got your stamp, go there quick because there's only 2 stamps there and there's so many of us, so that's all right. And we can win some good prizes, so looking forward to seeing how many of those we can get. Lego, that's right up my alley, so this will be good. All right, why are you all here to listen to me? I guess I've been working commercially in software development for over 20 years now. I guess that makes me about halfway. Hopefully only a third, but we'll see how we go. It's everyone else here knows that. It's a long life. This doesn't make me unique, certainly amongst the crowd here today. But it's not all software. I've got 2 teenage kids. My eldest turns 18 this year, so that's, I'm not sure, daunting, exciting, we'll see. But may the 4th be with her, because that is when her birthday is, which I've just managed to engineer very well. I guess from me and where I've come from, following my kids around, I've been a scout leader, lots of different sports, AFL, basketball. Right now I'm coaching 5 different basketball teams this season. And through all that sort of participating within those community groups, especially in this day and age, everything's IT. So you get to meet a lot of people who have a lot of strong opinions about what is IT and what I can do to help them. Heard a lot of IT problems and horror stories. So I started off, I did my time in tech support and sort of progressed, as most of us do. I've had the opportunity to work mostly in small dev teams, but I think 12 would be the largest, and collectively we've won government contracts both in the UK and Australia. We've done the ship box products back when that was a thing, and churned through plenty of time, just earning dollars per hour, just doing consultations as an ISV. But had the opportunity to produce many websites and point-of-sale software for big names that we probably know, things like Harvey Norman, Spotlight, and Stanford University, Harvard University. So from these placements, some of them I came into after they had succeeded, and sometimes well before. And a couple of them had a rare opportunity to actually be a founding startup member and have followed it through to market. Not all ideas make it, and it's not always because of me. So just quickly on why any of this matters, we've just got some quick stats on startups. Now, this is something we've probably heard for a long time. This stat hasn't changed in about the last 15 years, which is interesting. So only 9% of any startups in any industry actually survive to 10 years. Now this is across all industries, but of which IT, AI, and software development in general, that makes up almost 30%. So this ratio, 9%, is still very relevant to our industry. If we can think of that in a different way, 9 out of 10 startups fail. So if you have ideas, just remember less than 1 of you will make it. And that's not necessarily to be a bad thing, but just be aware of it and sort of embrace it as you go through. There will be plenty of things you'll experience. You'll write code, it will have to be thrown away. If you can embrace that, then you'll make it through. So 4 out of 10 startups actually make a profit, but only 1 out of those 4 will actually make it, like really make it. So today, I want to focus on that 40% of startups that found a market fit. They made it profitable, but they still struggled and ultimately failed. The physical ability to scale your product and the way you produce it to meet the demand as you grow is a key factor that will decide whether you are in that 1 who's on top, that 1 in 10, or you're in that 3 that didn't quite get there. And that'll be our focus. So, as an exercise, I'll try and see, the lights are bright. Who's working on or has worked on monolithic projects before? Just raise your hands. It's a bit of everyone. That doesn't surprise me because according to Red Hat, I did actually try to use ChatGPT for some statistics. Don't do that. They were really not reliable and did not help my arguments. But Red Hat, most of us in the room would use some of their software and would trust them. 75% of enterprises, this was a survey done this year, they still rely on monolithic applications. So if we take that back a step to that 1 in 10, then 75% are still using monolithics. So that gives us a bit of comfort that monolithic applications aren't necessarily dead, not yet, and they are a simple way to get your idea out into the market. So without significant seed funding, most startups are going to start on shoestring budgets. They may have a single developer, and that single developer is probably the engineer, the architect, the tech support, and will be talking directly to product owner if that's not also them. Hopefully we don't get involved in sales and marketing, because that is a very different skill set. So physical hardware is often really appealing when we start development. We'll work on our development machines. There'll be old PCs around. Most of us would have pretty old hardware that's sitting there doing nothing. In the startup sense, they're fair game, and that's where you'll start. And so the monolithic application structure works really well for that. We have one box, and we need to get something running. We need to get MVP out the door. So there's an allure to microservices. I think everyone has sort of bought into the hype, and it's for good reason. But to start off your application development with microservices in mind is a really, really expensive exercise. If you were to push to Microsoft Azure or even AWS, it is technically possible to run cheaply, but just the upfront infrastructure that you need to set up, they have minimum spends, and they're going to be well and truly out of your budget if you're not on a sponsorship. So choosing a monolithic application is often a calculated risk. It's one we all accept, and we generally say once we have enough paying customers, we'll have the time to pause, come back, and reevaluate our architecture. Some companies who've recently done this, is everyone aware of Atlassian? Use Jira or Confluence? Okay, so Jira and Confluence started off as monolithic applications. In fact, they were box products you had to install on-premise. And it's only once they had multiple independent international teams of developers, so they had head offices all over the world, it was only after they had really established themselves that they were able to take that leap and move into a microservice in architecture. Last year, I don't know if anyone would have noticed, Amazon Prime actually moved back from microservices to monolithic architecture, and that reduced their runtime cost by 90%. And for those of us who get up on Stack Overflow is still a monolithic application. So let's define monolithic though, because I think my view is a little bit different to what you'll read in textbooks and what we'll read if you would ask ChatGPT. So monolithic architectures are not always large, but they are generally managed in a common repository, usually by a common team of managers, designers, testers. Everyone's sort of working on one thing. And so perhaps I should have put up there on my slide, there's a mono vision. So I deliberately used mono so we can see what's going on. That's not to say you couldn't design a microservice architecture around similar constraints, the size of our team, and the servers we have available. But when you try to run microservices yourself, if you try and architect that framework all on your own and you do the individual services, it's very easy to cut corners and accidentally create logical or usually physical dependencies. And once you have dependencies between those services, it's not really microservices anymore. So if you manage your application development in a single unit, or you can visualize it on a single Kanban board, then you are probably applying monolithic management practices, and you're going to end up with monolithic architecture. So using containers does not make you doing monolithic. Does not make you not a monolithic. That's a deployment style available across any architecture. Even if you compiled your application into multiple services and multiple container deployments, if all of those those components need to be deployed together as a single unit, or if there are some types of changes you can make to your code which will then cause you to have to wait and stop everything and redeploy every service, then that's monolithic. So CI/CD should still be used in monolithic. A lot of people would assume that once you're using those DevOps practices, you're probably moving away from monolithic. But monolithic will fail just as quickly as microservices will if you don't embrace DevOps practices in this modern day, especially if you're going to do web applications and cloud-based distributes. So if you aren't using continuous integration, testing, and deployment, then you're really going to struggle when we talk about scale. So let's have a quick look at 3 common monoliths. Let's look at a traditional N layer. This is a picture we're probably all aware of. This could be a single solution, perhaps in Visual Studio, with multiple projects. That's fine. But you're going to deploy it. This could be a box product. This might be deployed as a single MVC website, for instance, would be monolithic. You're going to deploy that to a single server, and generally it has a single database. One of the great things about N-layer is that when we start to talk about hyperscale, N-layer comes back into the picture because we constrain the user to a single set of hardware. So if that hardware fails with that user, they don't affect anyone else. So there is a point in our scale where we actually come back, and microservices is really like distributing multiple N-layer implementations. So N-layer still works. If anyone's used any of the Microsoft patterns and practices, there's examples of clean architecture, or you might have heard of it as onion or hexagon architecture. They're all just N-layer. It's a way to organize your code, but it's still a monolith. So yeah, in the long run, this will turn out to have the greatest performance, but it also has the highest cost because we're going to restrict a unit, a number of users into one server or a common set of servers, and then we won't let them go out to others. When we do want to go out to scale, if you had a box product, for me, we had some financial products, which it was, yeah, a good 20 years ago now. That was a physical box. I've still got heaps of them at home. We thought it was cool at the time, and there's too many. When our customers come back and say, now we want remote access, now we want to be able to, this was before work from home, and now they would want to work from home. We want to integrate with, maybe they're using MYOB Online or Xero, and that becomes really, some of those integrations become really hard if your software is installed on the customer's infrastructure, if it's on their personal PC. So often we use VDI to lift those N-layer monoliths up into the cloud. And you might use, in the past we would use Citrix or remote desktop services on the Microsoft stack. But by doing that, there is significant licensing costs. So if we now go to Azure with VDI, it's cheaper, the licensing is cheaper, but you still need the hardware. So it's still quite high in terms of costs, but this architecture works really well if you have high CPU or RAM requirements. If your product needs to scale up because of the way you've written your application logic, then N-layer works really well. It just doesn't work too well for scale out. To achieve large scales, N-layer just has practical limits in terms of the number of CPUs you can put in a box. So even if we move the database to a common, maybe it's a cloud database, and you've still got the application installed on everyone's machines, you're still going to hit bottlenecks with the number of connections to the database. If this is SQL Azure, you're stuck at 180 concurrent connections, and that's not individual users. That could be your code, could spring up all sorts of connections. So it looks really appealing in terms of scale out. Oh, we'll just move the database. Oh, we'll just use replication in the database. But it gets quite expensive to still deploy your code if it's in someone else's infrastructure. So the first solution to N-layers problems was N-tier. This is probably the one that we're most familiar with, if anyone is working in the .NET stack, in that we would have multiple web front ends, probably deployed out into a farm. There'll be load balancing between them. We could deploy the API stack for business logic. Again, we could scale that independently. And in this image, we've got 3 APIs, 2 front ends. The front ends generally run on the client. So most large applications will still get away with, if it's a SPA app, you'll get away with a single web front end. And you might have 2 for just so it's redundant. But the code runs in the client's browser, so you don't actually need CPU. You don't need a lot of RAM there. It's just downloading the files onto the client's machine. Again, we can separate the storage tier to have multiple databases. We can scale those out. We can shard them. There's a lot of options in any of the cloud providers today, and if anyone's using databases, you're very familiar with them. We don't need to go into them. But there's still, if you look at the arrows here, we've still got an issue where all of our calls to the database come through, they funnel through the API. So we need to be really careful that our APIs don't run the same way that we did with NLayer, where the database was sort of next door or on the same PC. We need to be a bit more careful about actually caching the data that we want from the server and being selective in what we request. So when we go into end tier, we tend to get restricted by HTTP request rates, not so much CPU, because we'll have auto scale. So we've dealt with the CPU load, but we're gonna clog up the pipes, if you like, with too many HTTP calls. So latency between these layers is still a problem that's going to constrain our overall ability to scale. The last monolith we're going to look at here, and I will come back to why I'm going to call these monoliths, is really just an extension. We take end tier, and then instead of having direct HTTP calls back to our business logic layer and then business logic hitting the database directly, we try to offload any busy tasks. So any heavy lifting, we try and offload that through queues and have separate worker processing modules. So if we're in, I should call out AWS, I don't use their services, but they have them. So if you're using Lambdas, then you can still be writing monolithic code, even though you're going to deploy some of your logic out into these functions or Lambdas. You might just be deploying to a separate virtual machine. You might have something really intensive, image processing, and you'll spin up a virtual machine and actually run some code through there. But you use the message bus to talk between the layers rather than having the API go directly. So other names for this type of infrastructure that sort of fit here is SOA, so service-oriented architecture, CQRS, so command query responsibility segregation. That can still be, we can still deploy like this and it can still be monolithic. Even event-driven patterns would generally fit in here, and the way we would write the code, the way we're encouraged to write the code when we grab the patterns from Microsoft and the startups, it's still a very monolithic experience. Even though we're deploying out to multiple servers, we're still managing it as a single unit, and we'll do minor changes, sure, we'll push hot fixes out to individual servers, but there'll be a time where we make fundamental changes to the core, and we will have to redistribute our binaries to everything because we've got a common data schema. Maybe we've added a field, taken out a table. It's going to happen. So if that happens to you, if you find yourself, if you think I'm doing microservices, I've got lots of little services, but you find yourself having to pause and redeploy everything, then that's monolithic, and that's why I included here today. So the other thing to notice about here is that each one of these architectures is increasing in complexity, but if we were to look at the code and the structure of the project is very similar. Within layer, we might split out the code into separate projects. Within tier, we've just got separate executables, and then with the web queue worker, we're moving more executables again. We're just splitting up the surface of what can execute code just into smaller chunks, but it's still the same experience. It can still be a single solution within Visual Studio. And we can even have a single button click to deploy the whole lot. We set up pipelines. It's not very complicated. This WebQ worker can evolve into microservices. So the big takeaway, I guess, from this layout is that in the startup world, we tend to start with end layer just by default. We need to get something quick and dirty. We need to get our MVP out so that people can verify the product and we can test it. As we scale that application, the next logical step is just to try and deploy those tiers to separate services. So you might even deploy them as N tier within a single server environment, and then later we just choose, let's push that out to separate servers. WebQ Worker is the next evolution. It's really taking those heavy workloads and just identifying what's coming through too fast from the client, and in our business logic, what makes sense, what can we delay and process asynchronously. So that's really the key, the using queues and message bus, or events even, but environment events, not just our traditional callback events within our code. If we migrate our mind and our thinking towards that type of logic, then we will be ready to take that next step when we can afford it to go to microservices. All right, so what goes wrong? It turns out that each of the previous architectures, they follow similar patterns of when things fail. The biggest issue is generally observability and knowing when things have gone wrong. It's not really cost effective to react when the user complains. If you have 5 users, sure, you can probably get by with that, and you can call each one of them up, have a meeting, and you can apologize when things go wrong. But it's really not a good business plan. So the key to being ready for scale is knowing what's going on. Are you tracking the right metrics? Can you detect issues before your users do? And then have you got notifications so that you don't have to be looking at a dashboard all the time to see what's going on? And that sort of takes time. So once you've got these metrics and you start looking at them, you need to understand what's going on. There's a lot of things you can read about the architecture that you're deploying to, and the physical limits, which are the ones we're always aware of, is the number of concurrent connections, the RAM available, CPUs, the number of threads and handles. All of those things are great, but you need to understand them in terms of your application logic. And some of these things won't be documented. This is your logic. If you didn't document it, it's not out there. And CPU, for instance, is often not a really good indicator for load, because we'll see spikes when individual things are happening, but it's, especially in a web architecture, they're really intermittent spikes. So if we look at an average over half an hour, it might be down, and you might miss things. So you need to learn from your environment what the right metrics are, and I'd love to go into detail, but we've only so much time today. But it's interesting just being aware that you won't know what you're looking for. And this is where machine learning and those sorts of approaches can come into it. So if you start to use these cloud providers in Azure, we use application insights, it would be a good idea to just flood it with logs, and you will get feedback from the infrastructure, from the platform, which will point you in directions, but then over time you'll learn how to customize the counters and the metrics, and you can really tailor it down to your logic. So it becomes really important to identify in your code what the definition of okay might be and set up health checks. It's not just, can I hit a status page which does nothing and measure the response time there? That's not going to give you a real indicator of your application being able to run. So each failure too, as you go through this, you're looking at it, you should probably adopt an approach where each failure comes up, you identify a metric that can tell you whether that is going to happen again. And so you use that feedback cycle when you've got a small number of customers, when we're in that startup phase. That's what you should be using your customers for. We want to test ideas in our application, but we also want to stress test our users and find out what annoys them and how we can prevent that happening from the next user. So the final step when things go wrong is that you're not prepared to deal with it when they go wrong. So once you've identified these issues from the customer, you've got to develop a plan for what you're going to do. When that issue happens again, what are the steps that I need to follow? What are the steps that someone else needs to follow? I guess the biggest mine shaft that a startup developer can fall into is that idea that you're going to be there to the end and that you will be able to answer all of the questions. I can tell you once 10, 20 customers, you can probably manage it. It gets pretty full on. There's no time left to code. But once you start having 100 customers, and maybe that 100 customers each have 10 users, there's a lot of things happening in any given day, and you can't even keep visibility over it yourself. You do have to handle these things. So the final thing that tends to go wrong with a monolithic deployment, especially when we're scaling, is that we deploy first, and if there's a problem, we'll go back, fix the code, and redeploy. So once you've got paying customers in your environment, you no longer have that luxury. So you need to make sure you've got a way to roll back. If you're using deployment pipelines, either through GitHub or Azure DevOps, then they will store the binaries so you can redeploy. So if you're in this room today and you are not using continuous integration and deployments, you really should, because if you're not using continuous deployment, that means you've got a very manual step, and it probably indicates that your reaction to a deployment that fails is to fix the code and deploy over the top of it as quick as you can. I've walked into many developer teams where that's just a given mindset. You talk about it and they laugh about it. It's like, that's what we do, we're developers. It is, and I've done it, but if you behave like that, you won't be that number 1 in 10 that makes it. So I thought let's have a quick look at a first year of a startup, just to highlight a few things that go wrong when you think everything's working. So this chart, basically we got the big blue bars is data, and the lines, we've got some lines that indicate users, number of tenants. So probably when you start off, you've got 1 tenant, there's 2 users, it's you and your mate who are developing, and probably only one of you is actually using the system at any time. That means that early on, when you're testing, you're not testing under load, and you're not really using the whole system, you're just testing the module that you're coding, and you move on and you say, yep, that worked. So let's step in. The second quarter, we managed to get a new customer. It was probably the customer we were talking to begin with, so now we have a test tenant, we have a real tenant. That real tenant brings 5 users with them, but we're probably still training them how to use the system, fixing bugs, so there's really only 1 user at a time because their users still don't know how to use things. But at this stage, we've got maybe 50, let's use the number, 50 transactions. Let's say we created 10 transactions in the first quarter, and just as a relative term, once we got our users in, they started creating 50 transactions. In the third quarter, we go and bring on another customer. So now we've got 3 tenants, and 3 is a magic number in the development world, because when you try and implement multi-tenanted software, the first one's a test one, we don't care about it. The second one's a real one, and everything works for them because there's really only 1 tenant using it. As soon as you've got 3, you've got 2 real paying people who are messing with each other and getting in the way. So at that first start phase of your software journey, will be critical that you can sort out that tenancy, but it will really prevent you from moving forward. So let's imagine you can move forward. Everything's looking good, our multi-tenants are working, we've got maybe 4 or 5 concurrent users. There'd be 20 users, but there's only 4 or 5 of them clicking buttons at exactly the same time. That turns out to be a key thing a bit later. But everything, at the moment, it looks good. So in year 2, you can see year 1, our graph's like right down the bottom. We've disappeared. Things have skyrocketed. We onboard 5 new tenants. You've doubled your customer base now. But what's a bit interesting is that you've more than trebled. In fact, well, those numbers, we've gone 7 times as much data in the same time period. And this is now where we start to pick up issues in reporting, especially over year 2. We're going to get our customers doing end-of-year reports. There's going to be financials in there. The first year, we're going to fix their issues. It's probably just going to work. We're not going to be worried about performance because there's not really enough data to slow things down. We're looking at CPU usage at this stage. We're like, yeah, our server can handle this. Maybe once or twice you've scaled up. You've just added a new CPU, added some more RAM to your servers, but things are good. We fast forward 2 years. You can see we've had a rocky road with some of our users. That's the orange line there. We've been steadily onboarding tenants, and as we go new tenants, we seem to be getting, in this model here, I've used 10 users for each tenant we take on. It's a linear scale. But what happens is with your success and your customers start to have success and they start to get really proficient at using your software. So before, when you had modeled this, you said, yeah, it's cool, we can run with the user count we had. After a year or 2 of your users using your software, they get better at it and they start generating more data a lot quicker than we had previously modeled. And so it's usually around the 4-year mark where we start to get issues with data and everyone's putting their hands up saying, why has this never happened before? Why are things slow now? What's going on? We've only just onboarded 1 more customer. Why did 1 more customer just cripple the system? So let's zoom in on that because it's pretty hard to see those lines there. Turns out, so these charts have different numbers on them, but the shape of them follows very closely to one of my products. If you add an extra 0 there, it's a bit closer to the throughput we were looking at. But it turns out we didn't notice this, but at the point where the transaction rate was going down, we had hit this magical limit, which for us in this, let's say it's 20 users concurrently. When we hit that limit with too many users hitting the system at the same time, there would be really minor spikes we would see in the CPU, but then immediately after them, the server just stops responding. And so what happens for these users is they get every other transaction will go through, and then every other time they're just waiting. And we made a little spinning icon, and the response from users after we put this spinning icon is it took 4 spins, and then there'd be like 20 spins. They started counting it, and it started becoming our business logo started to become the way that they tracked the performance of the system. So we stopped it spinning because it was starting to get some bad feedback. But we weren't really watching some of these numbers at the time. So one of the really important things is if you want to achieve scale, things quickly get out of hand. So you need to know what's going on. And at the start, you might think some of these metrics, concurrent users, is really hard to figure out how to track. So we deliberately coded it in. We've got concurrent logins. We had forced logouts. But we also, it took a bit to actually get those numbers so we could watch them. But they became really important because on days where, because we're operating different time zones, days where there's public holidays in some states, then we would see the system's fine. And then maybe there's a revenue import or something they're doing on a Monday, which is typically public holiday. That's actually how we noticed it. We looked at the trends of the days when the support tickets are coming through. And we're like, hang on, we need to know what's going on. So a key element to success when you're scaling, and if you can do this up front, is to just try and track everything, be aware of what's going on in your system. This is my favorite GIF that I saw, I don't know how many years ago, I don't even know how to reference it. One of the big issues with APIs is that if you're not careful, they will effectively DDoS attack your database. So you want to make sure that you are caching as much as you can to prevent re-entry into the database. For a monolithic especially, the database tends to be your weakest link. It's often the most expensive link, so we are constrained financially before we can scale it too large. But also, if we just have better coding practices, then we can extend the life of our small databases before we have to go into really enterprise stuff. So caching is really important, and it's a hard thing. It's a topic on itself to get right. But the other thing you can do in the .NET stack, it applies to any stack, but I know how to do it in .NET. You need to filter your data queries in the server as much as you can. If we look at some of the responses from ChatGPT, from Copilot, for even some of the Microsoft patterns and practices for using Cosmos DB, they guide you in a direction where you're writing your link statements, and it's very easy for you to write a query that makes sense and does what you want it to do, but it actually executes in your local memory where it's running. And at the start phase in your development cycle, you're not going to notice that that's a problem, because if it has to pull down a whole table worth of data, that might only be 20,000 rows. 20,000 rows is nothing. When it becomes 2 million rows, then it does start to become a problem, but it's a weird problem because it's just a bandwidth issue. So often you'll see that if you're monitoring your system, you'll be like, oh, our servers are downloading more, let's increase the bandwidth, or let's make that more efficient, when what you really should be doing is looking at that and saying, hang on, why is there so much data egressing from the database back into our logic stack? Why is that happening? Because it really shouldn't. There's a lot of processing you can do on your database, and if you're not using an enterprise database like SQL Server, Oracle can do it, you really should, because for the price you pay for them, it's a lot cheaper than trying to download everything and run in memory. The other common thing that can happen, I haven't put up here, is if you are using a NoSQL storage, so using document storage, but you're treating it like a relational database, then that's the common area where you're going to be pulling down too much information, because a document database doesn't do processing. It just does data retrieval. So you can filter, but it won't do any processing, whereas if you use a SQL Server database, if you're using relational data, you probably should, then you can actually do aggregate queries and heavy processing on the server, and the server's really good at it. It's close to the data, it's just super efficient. So you should use your database as much as you can. The last step to that, though, is that what you do bring into memory, the other killing feature of Entity Framework, and I perhaps wish it wasn't there, but there's people who use it, eager loading can cripple your system. So eager loading works really well if you're close to the database, if you're writing a Hello World application, and there are specific scenarios where it makes sense, especially if you are not entering into those navigation properties to pull back the data. So if it's only once or twice, fine. But if you're processing data in a loop and you're calling each of the navigation properties in that loop, then every iteration of that loop and every step is going to hit the database again to load the data. So you should eager load and don't be lazy. So bring everything up front that you need, but going back to the previous statements, make sure it's what you need, don't just bring everything. So Entity Framework, you would want to use projections. So is there some sort of conclusion here? Love to do a full technical dive into code solutions, and I did the first time I wrote this, and it's a bit deep. But monoliths can scale. You just need to know your limits, but those limits are within your architecture, your logic, and your financial situation. There are many options with cloud vendors. The sky is the limit, but you probably can't afford it, especially not in a startup scenario. So those limits won't be documented, the ones that are going to affect you. You're going to have to experience them, and you're going to have to learn from them. So be ready for that. Don't expect someone to have a handbook that says these are the things you need to look for. You just got to start looking at everything, and you once you learn how your logic works, then the rest of it will make sense. So your success is linked to your customer's success. Sounds obvious. But don't base your projections based on the resource requirements of customer counts alone. That's not going to work. Different customers are going to use your system in different ways. You need to observe it, you need to learn from it, and you need to build your own patterns based on the data that you see. Don't just think one server can support 20 users or 200 users. It doesn't work like that. And if you treat it like that, you're not going to make it, not unless you shoot really high. So be prepared for spikes in transaction rates, and be expecting that those spikes, when you do observe them, they will lag after you've onboarded new customers. As they gain proficiency within your software, that's when you'll see it. So depending on how good your documentation is, will tell you how big that lag time is, but be ready for it. So the last sort of thing that's actually what I wanted to base it on initially. In multi-tenanted deployments, you want to consider restricting the number of tenants to a given environment. So partitioning, we use it in databases for indexing, but the same concept works for, as we scale up any step in there. So you might use a API gateway to funnel users from certain regions into certain areas. You might choose to say, as a business rule, hey, we know our infrastructure, when we've spun everything up to max, we've got 8 instances, I can still only support 10 tenants in that environment. So as soon as I get 11 tenants, you should spin up a new environment. Don't try it. You can't just keep scaling the environment you've got. If you want to achieve hyperscale, and this is what microservices does really well, it's really lots of environments that you have to start managing. So be ready for that and have a plan for it from the start. Cool. All right. Well, I don't know if we can do questions. I've run pretty fair over time there. But that's, if anyone's interested, you can find me on Code Mentor. It's getting pretty busy. I answer questions. I direct people to the right place to go. For a while there, it was a full-time gig. But look, now where I'm at with my software journey, I'm just here to help everyone else. So if you need help, post on Stack Overflow. If it's a well-written question, I'll find it. But otherwise, you can hit me up on LinkedIn or Code Mentor. And I guess we've got to thank sponsors, right? Everyone, get your stamps. Do the bingos.